So hi guys, today we have another problem that is string subsequence, and basically the question states that you are given two strings. One is this one, this bigger one, this one. Another one is two, this one, and you have to tell if the subsequence of this string is present or not, and you have to tell the and count of the presence of the subsequence. Means you have to check for all combinations of the subsequence and if and you have to tell the count of the subsequence that is present in the given string. So basically you can see that G is here, K is here, S is here. So one combination is present and another combination that is possible here, that is G, K and S. Okay, so this is how there are four combinations available. You can read here that there are four combinations available. These are the positions that they are present into the main string. So this is the question that we have to solve for today. And what can be the approach? You may think like, okay, so it is a question of subsequence, so we can apply LCS, right? But what actually LCS does? Basically, LCS tells us the longest bound subsequence. This is the longest present. So we usually calculate the length of the subsequence, right? But here we cannot calculate the length of the subsequence. Basically, we have to tell how many times the subsequence is present in the S1 or not. So we have to modify the LCS approach a little bit, then we can achieve the target. So how can we do that? Let us discuss for that. So you may familiar to this graph, sorry, this tabulation. So if you don't know what is LCS, then I would suggest please watch LCS at first, then it will be easier to you, or at least you have you have some concept of DP, then it will be easier to you, I guess. So let us discuss for this tabulation how this works. Now, first of all, let us tell you the base case. Basically, you can see that all the upper row I have filled with one. Why? See, uh, what this cell means. This cell means that this part, suppose this is, let us say this is S1 and this is S2, and this cell represent us if this S2 is present in S1 or not as a subsequence. And obviously, you can see that only Z is present in the S1. So this is the meaning of this cell. Okay. So for this cell, particular this cell, what it means basically this part. And what this dash means basically the null set, the null entity. Suppose you are given two sets. Let us say this is S1, this is S2. So this is sure that there is already a null set present in every set, right? So for this part, I can tell that this null is present into this part, this set, right? So what can be the subsequence? That is this null and this null, they are matching. So I can put one here. Obviously, it is true. So for that, I have put all the ones here. You can take any other examples that is, suppose I am taking this part and this part. Obviously, this null is present here, and this null is making a subsequence. So here I have put one here, right? So this is why I have put one for first row, and now for these zeros. What this mean? Suppose I am talking about this part. So G, K, and null. So null G, K, this is present in this part. Obviously not. So this null G, K cannot make a subsequence on this null part. So for that, I have put 0 here. So the base case are clear to you, hopefully. So for the initial row, all the values will be initialized by 1, and for the column, it will be 0 except the first one. Because obviously you can see that this null and this null make a valid subsequence. Okay, so let us try to fill these cells, and let us talk about this cell. Now, what is does this cell means? As I have told you that for this part, they are matching. Already you can see that G is here, G is here. So I can tell that, okay, so if I reduce G from here and G from here, then where's the answer will lie? Answer will lie here, right? As LCS concept, it will be same as it is. But in LCS, we usually add one to here, right? But we cannot add one because I'm not talking about the length. I'm talking about the possibilities that we have. So I have to put one here, and we have to check for this value. Why this value? Basically, in this part, suppose there are more elements. So in this part, it will contain the previous part answer, right? So we have to consider this value also and sum with the current value. Then we will get the proper answer. Currently, you are not getting my point. Okay, it's okay. Let us fill for the next cells. Then it will be clear to you. Now see for this part. This part. Okay. So what will be the answer here? Obviously, G and E are not matching, but we have G and G in previous part. So already we have some valid points, that is one. So you have to keep this value here also. Basically, we have to carry this value here. So it will be 1. So as I have told you, the E and G is not matching. So the previous value will be carried out here. Now it will be 1 as it is. It will be 1 also. 1, 1, 1. Now you can see that G and G is matching. So where the answer will lie, that is in this part, sorry, in this part. Okay. So what is the answer for here? That is 1. And what is the previous value that we are carrying? That is 1. So 1 plus 1, that is 2. It is obvious because you see, if I have some value in the previous part, means I have in this position, I have a valid point, right? In this position, I have a valid point. And here I can see that G is appended with this part, right? So this G and this G making a valid part, and already we have one here in the previous part. So you have to add this one and this one here, right? So our answer will be 2 here. Okay. And now I have to carry forward this answer. So it will be 2 as it is, 2 as it is, 2, 2. Okay. Now come to this row. So what will be? Obviously, G and K are not matching. So you have to keep this previous value here. So it will be 0. It will be 0 as it is, 0. Now K and K is matching. So where the answer will lie, that is here. We have to take this value and add this previous one also. So this will be 1 as it is. And for here, it will be 1, 1, 1, 1, 1, 1. And now you can see that again there is a match. So we have to check for the previous answer, that is 2, and what answer that we are carrying forward, that is 1. So you have to sum it up. So the answer will be 3. Okay. So 3 will be here as well. So now here S is not matching. So obviously we have to take this value 0, 0, 0. And here you can see that there is a match. So obviously we have to take this value and this value also. So the answer will be 1, 1 for here as it is. And now we can see that in this part, S is also matching. So in our previous answer, that is 1 and this is 3. So it will be 4. So our answer will lie here, the ultimate answer. Okay. So this is how we can solve this problem. Basically, in summarize, we are just checking for the previous value that we are carrying forward. And if the instance of the element is matching, then we have to check for the previous one, excluding this k or suppose this k. Okay. So basically, this is the approach that we have to do. You may think if you do not know what is LCS, you may not understand this concept. Okay. So it is obvious that try LCS at first, then come to this problem, then it will be easier to you. Okay. So let us try to code it up. Let us declare all the variables that we need. In will be site, aim will be s2 dot site, and the mod will be 1 e9, sorry, plus 7. Now let us declare the BP array in, sorry, let us take that. Uh, it will be DP, and what will be the size? That is m plus 1 in n plus 1, and initially all the values are 0. And we have to initialize 1 in the 0th row. So in I is equal to 0, I will be less than equal to how much? That is n, then I plus plus dp of will be 0, I will be 1. And for other values, it will be as it is. Now let us calculate for the intermediate values. So it will be 1, I less than equal to how much it will be? That is n, sorry, not n, it will be m, I plus plus, and j will be 1, j will be less than equal to n, j plus plus. Okay. So now if the values are matching, then we have to check for the previous two values. That is a is 2. Let us check for that. Yes, it will be s2. S2 I minus 1. If it is equal to j minus 1. Why I minus 1, j minus 1? Basically, you can see that I have added one row and one column. So they are shifted for one values. So I have to reduce minus 1. So that is why I've done here. And it will be dp of ij is equal to dp of I minus 1, j minus 1 plus the previous value. That is dp I j minus 1. And if they are not matching, then we have to simply add bp ij will be bp I minus, sorry, I j minus 1. So now let us return the answer, that is dp, it will be m and n, and plus, sorry, mod will be applied here, and here I have to apply mod also to keep the values in the range. Will be mod, will be mod. So let us try to run the code. Okay, so the answer is not matching. Let us check for the issue. Okay, so I missed else here. Okay, so that is why the answer is not matching. So let us try to run again. Okay, it is matching and submit the code. So yeah, it is working fine. And this is how you can solve this question. And thank you for watching. And obviously, sorry, at the time complexity, I've missed that. Time complexity will be obviously n into m, the size of S1 and S2, and space complexity will be as it is same. So yeah, this is the approach that we have in this question. And thank you for watching and see you in the next video. Bye.